Excellent. I think it's a good spot to start. I think more people will fill in.
Okay.
Yeah, cool. So, those of you that are new, my name is Kirby Downey. I run the London SWGN. SWGN stands for SolidWorks User Group Network. There's literally hundreds of user groups around the world in different cities, and that a lot of user groups run virtual meetings, a lot hold in-person meetings. So this will be another one of our virtual meetings. Beauty of that, I can get people like Josh Mays to join all the way from the States for during his lunch break. So I do appreciate Josh you joining in.
Yeah,
I don't
sure.
recognize the face. He's Josh Mays. This is a person I met at 3D Experience World and through the user group network, and a really fun person to be around. And you primarily do CAD admin type of stuff, but you've got
Yeah,
some tricks under your sleeve.
I do. I've got a long history of design engineering before I got suckered into administration.
So I'll just hand it over to you. He's basically going to show us how you can use Excel to do configurations, which
Yeah,
I'm quite fascinated to learn about myself.
cool. Yeah, I'm just getting my screen arranged here. I think I've got things ready to go. This is my first time on the Bevy platform, so a little bit interesting, but let's see what we can do here. And I'll try to keep my eye on the chat, but Kirby, or if you could interrupt if there's any questions that come in on the chat, I would appreciate that.
Can do.
And let me try sharing screen. Entire screen. That one. And
Looks good.
let me know if you can see my presentation.
I can see it.
Okay, cool. All right. So, yeah, thanks, Kirby. My name's Josh Mays. I have a bio slide here. I'm currently the senior CAD and PDM administrator at the University of Dayton Research Institute in Dayton, Ohio. We serve primarily the U.S. Air Force is the majority of the work that we provide right now, um, and do a lot of reverse engineering, some 3D printing, scanning, that kind of thing. A lot of metal 3D printing as sustainment of aircraft components. So I've been using SOLIDWORKS for over 25 years. I think I should probably stop counting at this point, but yeah, it's probably been 27 or so now. Um, Design engineering background, lots of different types of products and designs from special machines. Early on when I was doing board drafting, actually, to automotive industry, my first time using 3D CAD. Um, was in school, very quickly got a job using Unigraphics software. Um, Same kernel, totally different software. Um, did some reverse engineering in SolidWorks for Indian motorcycles, which was pretty cool. Got into the interactive kiosk market and did that for quite a few years. Did some rapid prototyping and rapid tooling, um, again using metal 3D printing. That was my first time with metal 3D printing. Some injection molding, tooling, things like that. Industrial robotics, electric motors. Electric motors is actually where I really got into design tables. The company that I worked for, you can imagine with electric motors, the design from the design side, it's kind of boring. I'll admit there's a lot of similar components, slightly different, but that lends itself to design tables very well. For example, we had 20,000 shaft part numbers, lots of variations, different diameters, lengths, bearings, uh, interfaces, bearing journals, um, keyways, flats, all types of different end conditions. So it was almost everything we did was a charted drawing. And if you saw my screen flash up initially with SolidWorks, you saw an example of a charted drawing when I got started. So we'll talk about that. Cots and stretchers, I did that for a while. That was a fun business, serving the EMT market. In fact, company I work for has an office in the UK. And now, like I said, aerospace and defense is primarily what I'm serving through the Research Institute at UD. I am also a SWGN leader, co-leader with Isaac Bear for the Miami Valley SWG, which is a little bit confusing, not to be confused with Miami, Florida. This is the Miami Valley of Ohio. And I'm a SOLIDWORKS champion, a CSWE, a CPAP, which is the PDM administrator certification, and 11 other certifications or total certifications. Kirby and I met at SOLIDWORKS World. I think we met, can't remember if we met virtually or in person first, but yeah, we've
I think
known
it was
each other now.
2019.
Yeah, for a while. So I started, first World was 2016. I missed the year after that, but I've not missed one since, and I intend not to. They're really fun. And if anything you remember about me, it's that I'm passionate about SOLIDWORKS, and I try to spread the red, which is the SOLIDWORKS passion. And the pictures there you can see um, Manish, CEO of SOLIDWORKS, getting a selfie with me for showing off my red. You usually see me at World wearing red, and there's me and Kirby as we got together with Sean O'Neill, who was the original champions leader, um, and he had just arrived in Nashville. So with that, they spread the red. This is a funny example. So this is 2014. These are all the user group leaders and champions on the stage getting our picture taken. You can see, can you see my cursor, by the way?
Yeah, we can.
Okay, cool. There's Dan in the middle with his red shirt. Over on the far right, Matt's got his red tie on. Those they had just been up on the main stage talking about the SWGN network and the Champions program. And then you can see me in between with my red hat and bandana. Um, and then not many other examples of red there. But you go to 2025 last year, and the red had spread. So pretty cool. A lot of passionate SOLIDWORKS folks in the community, and I'm just one of many. But I'm glad to be here and hopefully help you guys learn something today. As Kirby mentioned, the user group network, um, our mission is to empower you guys, collaborate, and learn from each other. And so I changed the slide a little bit just so you could see Kirby and Johnny both down here. And all right, so let's dig in. If you have any questions, like I said, feel free to put those in the chat. Hey, Craig, I just saw Craig's on the chat. Thanks for this. Vermont user group is also joining us today. Thanks for joining. And so we're going to talk about why we use configurations in general, and specifically why do we use design tables. And then I'll show a demo with some examples, and we can jump back and forth depending on what questions you have. So why do we use configuration? So um, I presume we've got a mixed audience, but some people probably have a lot of experience with configuration. Some may never have known they were available. I'm kind of surprised when I talk to new people in the company or um, interns that come in that are getting started with SOLIDWORKS, and no one's ever, they may have taken a SOLIDWORKS class and never talked about configurations. To me, it's one of the fundamental, really important tools to learn. So
Yeah,
what is it?
so when I say I only learned about configurations by doing the CSWP exam.
Oh, okay, nice. So yeah, so what are they? They give you the ability within a single CAD file to do different things. So it's similar but different is the key. And it allows you ease of management to manage what I call part family. So anything that, in this example over here on the right, this little bracket, it's a simple design, but you can see two different variations here, one with a larger version with 6 holes, and a smaller version with 3 holes. And that was done, as you'll see in the demo later, with a single part file for the bracket, a single part file for the screw, and the part file, the screw both have a design table, and the assembly has a design table. So everything can be driven with those 3 models in that example. We can easily make copies, right? We can do save as. Everyone knows how to do save as and make a copy. But as my prior CAD administrator told me, copy is a 4-letter word, and I like that. And like with most 4-letter words, they're appropriate in the given time and place. But in general, they should be used with caution. So what I mean by that is, if I have certain features that are common, that's what makes a part family, some commonality, right? Um, Families have something in common, some DNA, some common denominator that brings a family together. Um, you want to be able to manage that in terms of CAD model. You want to be able to manage that in one place with a single source of truth. You don't want to have to, you make 7 copies of all these variants that are similar parts and have to go make a change that affects all of them and make that change 7 times and hope you didn't miss any and hope you got it consistently right in each case. When you can make that change once and have that propagate to all the copies. And so that's the advantage of a configuration being in a single file. Configurations are easily changed within an assembly versus replacing a component. So if you've ever replaced a component in an assembly, let's say the screw, for example, I decide I want a different style screw or a different size. I don't want to have to go browse to and replace with a different file when I can simply just change the size with the drop down in 1 second. So that's something we're going to look at today. Some PDM or PLM systems might limit you on what you can do. So if you have a CAD administrator or if you're using a PDM or PLM system, make sure you're following your company's guidelines for how your part numbering is done. A lot of people do file specific part numbering, in other words, 1-to-1 or a file versus to a part number, where configurations allow you to do multiple part numbers within a given file. So just want to make sure that's just something to consider if you're implementing configurations, that you're doing so in a way that is still manageable with your file management system. Custom properties come into play, data cards, etc. So model states. This is something that we can use configurations for, and there's pros and cons to doing this on the first example here for cast and machined. But this example that I'm using here is actually one that I did the casting and the machining. This is intended to be an example cast part. And some people like, again, it comes down to that part number issue. If you have a file specific part numbering and you want a separate drawing with its own part number for the casting versus the machining, maybe you want to use a derived part instead of a configured part. So another one is in the 3D printing world. With metal 3D printing, for example, we use configurations. We have a mix of configurations and separate files depending on how we're structuring ours. So it's kind of what works for your business. But for 3D printing metal, we have the end item that we're trying to get to, the final part. But to get to that, we have to have the as-built part that's come off the printer. And before we take it off the build plate, we might have an as-printed configuration that has some supports that we design, some specialized support material that we design for those parts. So we have 3 configurations typically for a metal 3D printed part. Assembly variations is another one, and that's the example that I'll be showing later. So you can have a assembly variations like this variation has this component, this one doesn't. or it could be alternate positions. Maybe you just want to show your assembly with an access. Maybe it's a electrical cabinet, and you want to show it with the access door open and closed, or a drawer slid out or retracted. Those kinds of things. If only the appearance varies, I would recommend you consider display states instead. But sometimes the color, material, or finish will vary and actually be for different part numbers. So if you want to control that, that might be a good use for configurations. The sky's the limit, really. That's why I chose the clouds today for my background, because really there's, I, I could take, if I had all the time in the world, I could take every model in your database and put it all in one file technically, as long as until I ran out of performance, my computer wouldn't allow it. But the sky is really the limit technically as far as what you can do in a configuration. But I encourage you to consider responsible family guidelines. So with each part family, you want to kind of determine what, I know I can vary the world, but what really is the where's the responsible limit for what should vary within an assembly. So when I talked about those 20,000 shafts at my former job, we could have done all 20,000 in one part file if we were really trying to, but it made a lot more sense to say, okay, we're going to allow length to vary, but if the bearing journal size diameter varies, that's a new part family. Or we're going to allow um, the length of a flat or a keyway to change, but if it changes from a keyway to a flat, well, that's a different family. And so that helps you to just limit the total number of variants and keep the file sizes and the file management more simpler. So why we can do all those things that I just mentioned, all the configurations that I talked about, you can manually do. You don't need Excel to do those things in SolidWorks. And there's actually a configuration manager, which makes things easier than it used to be. It used to be really blind. So when I was using design tables back in the motor business, it was a situation where if someone didn't use a design table and they just go and start changing dimensions in this configuration only, suppressing features in this configuration, changing a tolerance in that configuration, all of those things, you wouldn't have any real visibility of what was what. And um, I like Excel because it allows me to see exactly what's intended to vary. Um, I'm old school. I like Excel. I use Excel for a lot of things outside of SolidWorks, and so it's familiar to me. Um, and it really is a powerful tool built right inside of the um, CAD file. So this is not an external Excel document. There's unlike equations, which you can drive with like an external, um, you know, text file. This is embedded in the CAD file itself. So it's really handy, and it allows me to use all the colors and formatting and formulas that I'm used to using, and it helps me to make it more clear um, for the next guy. I have this last line here: keep it clean and simple for the next guy. And I say, which might be you. You know, oftentimes we get into something, um, we dig into it, it gets complicated real fast, but we're in the zone. We're digging in. We got it. We made it work, and we might have used some complicated methods to make it work. And it all makes sense when you're in the moment. Um, now come back a year later and try to figure out what you did and how you want to make a simple change. And it's like, okay, what did I do to myself here? I made this too complicated. So always think about whether it's modeling or whether it's the design table itself. How can I keep this clean and simple so that the next person that opens up the file can easily follow what I did? And then we'll talk about these user notes rows and columns, which are really handy ways to do that. It's a really nice way to be able to add additional information. So you'll see in the design table, this tiny image shows length at sketch 1, width at sketch 1. Well, those aren't bad. By default, that would say D1 at sketch 1. So at least they've named the dimension, length, and width. So that kind of gives you a pretty big clue of what's being driven here in the table. But if other things are not as easy to understand with the coding that you'll see in these tables, and so you can add a user notes row and you can put a plain English column header of what this thing means. Or you can provide instructions to the user about edit. For example, I'll say edit only the cells in yellow and the white ones leave alone because we might have formulas in there. So another thing you can do is you can use user note columns to do calculations. So it may not be, maybe your file is in inches, but your input dimensions coming from the supplier, maybe you're tabulating a purchased component and all the dimensions are given to you in millimeters, but your design is in inches. You can actually input those values in the table in millimeters and have Excel do the unit conversion for you and drive the actual dimensions in a different unit. So we'll see that as well. Any questions so far?
Haven't seen any yet.
Okay. So we're going to get into some demo and examples now, the fun part. You've heard me talk enough with the PowerPoint slides here, but here's an example of some of the color coding and instructions that I've added. I'm going to show you this example, and this is for a button head socket cap screw. So why would I do this for a screw, you might ask? If anyone's used Toolbox, you know, SolidWorks gives us a pretty nice database of hardware out of the box, as long as you're using SolidWorks Professional or higher. And so, you know, I ran into this with my last job where we had all of this hardware and we were starting to incorporate, you might ask what this little yellow patch is here. This is a nylon patch, and it's a liquefied nylon that's applied to the hardware, and it avoids us having to use liquid Loctite. So I didn't know how to represent that using Toolbox. So we ended up making our own Toolbox library, and I tried to make it as simple as possible for people to add additional sizes, which was not a small feat. This was a pretty involved project for myself and another, actually the guy who's my current co-leader at the Miami Valley SWUG. Isaac was working with me at the time, and we co-developed some pretty cool tools related to hardware. But what we wanted to do is we wanted to visually show on the hardware, so when someone's using this screw in their assembly, they can make sure that that patch, that locking feature, is engaging with the mating part in the right location. And so the specific area where that application was done on the screw needed to be visible. And so if it wasn't for that, I probably could have gotten away with Toolbox and customized my Toolbox library. It can do different materials and finishes and part numbers and things like that. But this is how we chose to do it. So what else can we control? We've talked about controlling dimensions. We've talked about controlling features. Obviously, the configuration naming, that's going to be the first column you see in the table. That defines the different configurations. So each row is a different configuration. The dimensions and all the other things that we control for those configurations are in columns. And so one cool thing that we can control that I'll show is the hole wizard size. We can't control the type. In other words, on this example here, I have counter bored holes for these button head screws so that they sit below flush. I can't switch that to a through hole in one configuration and a counterbore hole in another configuration by simply adjusting the type in a column. I would have to actually suppress one set of holes and unsuppress a different set of holes with a different type. So that's not a perfect solution, because if I'm mating screws into one hole and I suppress it, now those screws are missing their mates in the other hole. So I would have to suppress the screws and the holes and then unsuppress them. It would just not be ideal. But size is enough. Oftentimes, that's I think it's cool to be able to just simply say, switch this from an M5 to an M4, for example, and that counter bore and all the related dimensions. I'm not managing the dimension for the through hole, the counter bore diameter, and the counter bore depth. I'm just managing one column that simply says M4, M5, and SolidWorks uses its own database to manage the rest, which is really cool. I can suppress and unsuppress features, and I can do the same thing using folders with groups of features, which is really handy. So we'll look at that with my casting example. And then components in the assembly, we talked about we can suppress or unsuppress the components. We can also do the same thing inside a part file. So one example I don't have to show, but I'll explain. When I was talking about doing configurations for my 3D printed parts, sometimes we want to show in the drawing an overlay of the as-built part and the end item part. So oftentimes with metal 3D printing, there's some finish machining that has to be done. You could imagine the same thing with a casting and a machining. There's usually some finish machining done to a casting to make it a final part, an end item part. If you want to overlay and show where that material is being removed, you can do that with a shaded view on a drawing to give people a nice visualization, or even dimension some of the intended material removal. And so I might have one configuration with the end item, one configuration with we'll use the casting example. As cast is one configuration, as machined or end item is another configuration, and then I might have a third with an overlay. Well, I want my end item, if I export that out as a step file, I just want the end item model. I don't want the other models. So I would like to use a feature to delete those, or a keep feature to keep just the model I want and delete all the other bodies and surface solid or surface models. So oftentimes I'll use that, and then I'll just suppress or unsuppress that feature in the other configurations where I want to show the overlay or the other alternate state. Hopefully that makes sense. All right, let's go look at some parts. So let me bring up SolidWorks. Here we are. Okay, so here's the button head screw example that I was talking about. And you can see, you know, in terms of managing this on a drawing, we've got a table here that we've developed, and this table correlates to the design table. Now, there is a way to bring the design table directly into the drawing, but historically it's had formatting challenges. It's what you see is what you get. It was an OLE object situation where the Excel would directly be. So however you save it in the CAD model, that's how you're going to see it on the drawing. My company wanted a more control over the look and feel and keeping it clean on the drawing. So we actually had I used Excel again, but just as a workbook to go and copy the values from Excel, paste them into um, my little worksheet, work aid tool. It would show me the other thing we needed was dual dimensions. It would format the dimensions in this dual dimension format, and then it would allow me to just to paste them into the drawing. So not a direct associated value back to the design table, but the workaround was that we at least copied and pasted through this intermediate tool to get the display we wanted with the correct values, and didn't have to manually type any of these descriptions or values, which was our compromise. Um, if we open the file itself, let's take a look at the design table and ignore this goofy display. I've been having some issues with this cosmetic thread for some reason. Okay, it's telling me. Well, that's a good error for you to see, actually. If I try to suppress that cosmetic thread, notice the first thing it's telling me is, hey, wait, you're trying to change something that's locked by a design table. Let me show you that setting real quick. So over here in the configurations tab under tables, here are your two different ways to manage that configuration besides manual. If I edit the feature of my design table, you'll see this option to block model edits that would update the design table. So oftentimes I'll turn this on because I want a user to see that. If I come in and start changing something in the feature tree that's controlled in my design table, if another user comes in and does that, they might not even realize there's other configurations or that there's a design table existing in this file. And even though they may know what they're doing as far as the change goes, I really want them to do it in the context of the design table to make sure that they're covering the right bases. Now, if you're working on something and you need access to a file, you're getting that block, and you can come in here and unblock it. Just make sure you reset that back to block at the end. So let me go in here. If I suppress this cosmetic thread, working. Now I'm getting errors that I can't see. Cool. It would be a demo without a technical issue, right? I don't know if you guys can hear that dinging sound. There we go. That was weird. All right, so we'll just suppress that for the moment. Maybe if I unsuppress it, it would. There we go. That's what it's supposed to look like. Thank you. Okay, so you can see here, I've got a cosmetic thread just showing that this is a partially threaded screw. I've got my patch lock that we talked about. Otherwise, this is just a normal button head screw, right? A certain length and size. This happens to be a part family for M5 button head socket cap screws. So could I make a design table that gives me every size button head cap screw under the sun? Yes. But in this case, this is where I set my family guidelines. I said this family is going to manage only M5 size button head socket cap screws. So if you want a socket head cap screw, that's a different part family. If you want an M6 size, that's a different part family. And you'll see, even with limiting to M5, there's still a lot of variables to maintain. So we're going to go ahead and we're going to edit the table. So we did edit feature before. We saw some of the settings. We can block model edits or allow them. These are just kind of the typical, like, what do you want to see when you open the design table? Do you want SOLIDWORKS to tell you if it recognizes new parameters, new configurations, etc.? And yes, I usually check all those boxes. You can open this in two ways. You can just do edit table, which I prefer. Even though it's a little quirky, it tends to be more stable in my experience. You can also edit the Excel in a new window, which is helpful sometimes, but I've actually seen SOLIDWORKS and Excel kind of get disconnected where it kind of locks me out of my SOLIDWORKS and I have to kill it. So I tend to find more reliability on just the regular edit table option. So I'll show you the quirkiness of that and how to deal with it. So what's popping up for me on my other screen here, you can see, and I love this dialog box because this is how I have confidence that something outside of the design table hasn't changed. And so with that, if I don't have that block edits turned on and something changes in my model, maybe I add a new feature and I start configuring that new feature manually. This is going to pop up and show me, hey, I see something new here, a new parameter. Do you want to include this parameter in your design table? And you can select it and say, okay, and it will add it automatically. I wish this little box would stay checked. It's a little bit of a pet peeve of mine, but I always check that box because I want to see every time I come into the design table, I want to see this information. If you just click OK, then it will hide this again until the next time you reopen the file. So I'm not actually selecting any new parameters. I'm just acknowledging that dialog and clicking OK. And then one other thing that's popping up here, which is interesting, is it says the design table is large, maybe slow to load with cell drop-down lists enabled. And it asks me if I want to disable those. And I'm going to say no. And I intentionally keep my design tables from getting too big. So this has never actually stopped me from doing what I need to do. And I like the drop down. So I probably would select don't show again, but for the sake of this, I want you guys to see it. I'm just going to click no. All right, so now I'm in my design table and you can see what I've done here. So I've taken advantage of this first column, A, is actually, it's actually what defines my configuration names. And I've taken advantage of this top box here to just give some instructions. Somebody comes in here and sees this, especially if they're not used to working with Excel, this might be a little daunting. So I want to explain what to do. So you want to enter the charted part number in the first column. So let's just go ahead and pretend I'm going to add a new number here. Okay, so let's just copy this one and we'll paste it down here and we'll give it the next number, 20. Okay, and you may have noticed when I entered 20 here in this yellow field, I get 20 over here as well, because this white cells are equation driven. If I click there, you can see it says equal to cell A24. So again, I'm trying to control the data with single source of truth. I want to enter the value once. And so it says enter the charted part number in the first column. Exception, leave default as the first configuration, and enter part number for drawing only in second column B. So the second column description, actually it's not the second column anymore, I just realized. It's column E, the description, configuration description says for drawing only. And I wanted that to be clear that this is the example that I chose. It's not a real part number. This number is the drawing number that is what's going to be displayed on the drawing. And then these are the real part numbers below. All right. Enter values, and this is the key. Enter values in yellow colored cells only. White colored cells may contain formulas and shall not be edited. And then be sure to maintain all formulas and formatting when adding or deleting rows. So that's why I did a copy paste of that row, because I wanted to make sure that I got all the same formatting in this new row. So if we just go, by the way, when this gets big, freeze frames is nice. Unfortunately, freeze frames doesn't stick with design tables. So you can turn it on, and I will for the sake of this demo, but just be aware that freeze frame, like if I scroll over here, I want to be able to see my part numbers. If I scroll down, I want to be able to see my column headings. That's great, but it's not going to stick the next time you open it. Just the nature of being embedded in SOLIDWORKS, I guess. So let's look at my new part. I've got first column is my configuration name. Second column is my part number. And notice that the code here is $PRP at part number. That if you haven't seen that code before, that refers to your custom properties. So I have a custom property called part number that I'm using a formula to inherit the configuration name, because I want my configurations named by part number in this case. And so I've tied those two together. And now that's going to save that custom property value to my file, which is going to be useful downstream when I use this in an assembly, that my BOM is going to display this value or this part number. Okay, so that's a critical one. The other thing that I'm controlling is the revision. You can imagine if you are doing, multiple part numbers in a part family or a charted drawing, each of those part numbers, each of those designs can change, right? They are unique part numbers, even though they're combined together here. So they each get their own revision. So I'm controlling that revision value for those as well. And then the part number, how it displays in the BOM, this $ part number property, $C tells it to use the configuration name. So not only I'm writing out the part number, but I'm also telling the BOM to use the configuration name. So no matter if I'm looking at like a data card variable in my PDM system, or driving my title block, or whatever the case might be, I'm going to get the same answer because these two values are. Configuration description is $description. And then I have $PRP at description, which is the custom property. So there's a configuration description, and then there's the description property. And I've also got those set equal to one another. And so for my new part number, we're going to just come in here and give it a new size. So I'm going to say the 55 millimeter screw was too short for my application. I need a 60 millimeter, and everything else I'm going to leave the same. It's going to be steel. It's going to use this zinc coating, and it's going to have actually, no, I don't want a permanent patch. I'm going to use the RP designation, which is my removable patch, which is that nylon that you saw earlier. And again, this is just another custom property, PRP at reference. Now this is where I get into the problem of inch versus metric. So I am driving my model with millimeters as my primary dimensioning. However, I also have inch hardware. My assembly uses a combination of metric and inch, or maybe some products use inch and some products use metric. But from this design table template standpoint, I wanted to cover both bases. So you can see what happens if I switch this input value, and notice this is the first time we see the user notes as a column. So I'm using this column and the next 3 columns, they're not, or next 4 columns, that none of these are driving anything. They're just giving me the ability to specify things in Excel that drive the actual fields, which are over here, these SOLIDWORKS dimension fields. These are what's driving. So these are in white, and because I don't want someone to edit this, this is actually using a formula, and it's got an if-then statement, right? So we have the power of Excel that can drive, and it says if this cell, H4, is set to English, then I want you to multiply by 25.4. If not, then just use the value from I24. That makes sense? So if it's metric, the values are going to be the same. But if it's English, it's going to multiply by 25.4. So you can see now my length dimension, instead of being 55, is 1397. Obviously, that's not correct, but that's how this works. So just wanted to basically illustrate the power of Excel in this case, is that mixed units are not a problem as long as you build yourself a nice template. Now it takes time to put this together, but in this case, it made sense for me because I'm reusing this thing on all of my various hardware. So, we put together this template, we reused it for many different types of hardware, and it paid dividends in that way. Go over here. Some of these other things, like the patch you saw, there's these 3 fields right here are actually features. So when you see $state at and then a name, that is actually controlling the suppression or unsuppression of those features. So each of these, patch lock removable, patch lock permanent, or patch lock special, you'll see those are actually features in my design or my feature tree over here. You can see those on the left. So notice that patch lock permanent and patch lock special are suppressed in the current configuration. Patch lock removable is unsuppressed. That's being driven by these three columns and with a simple S or U. Notice this is where one of those pull downs exists. And for some reason, SOLIDWORKS couldn't decide to do one thing. They give you three different options that do the same thing. So you have the full word suppressed and unsuppressed. You have S and U, or you have a 1 and 0. I don't know why that is. I like S and U. It's concise and it tells me I don't have to remember a 1 and 0 if it's on or off. It's just S and U, which is, it makes sense. And then if those patches are used, there are specific specifications for how this gets applied. And typically it's applied based on having the first couple of threads be free of patch so that you can get the screw started. And then there's some number of threads that get patched. And then there's an angle of like, does that patch go all the way around the screw 360 degrees? Or is it just sprayed on one side like a 90-degree coverage? So that example you saw earlier in yellow was a 90-degree coverage, where the permanent patch tends to get the 360. So I said I was going to use the removable patch for this configuration. So what I need to do is I need to unsuppress the removable patch. I need to suppress the permanent patch. And then I need to change my coverage to 90 degrees. Maybe. Cooperate. There we go. 90 degrees coverage. And now notice that my show thread column here is set to suppressed. I had that unsuppressed in my default configuration because I wanted to see that on the drawing, but I really don't care about that in the assembly. I do have a split line feature that actually gives a hard line, so I don't need the cosmetic thread because I've got an actual face defined as the threaded area on my screw. And so this is now what's driving the length, the thread length, the patch-free lead, and the patch length. And then this patch angle is actually driving directly. There's no conversion needed on the angle. There's only conversion needed on the length units. Okay, let's go over here. The last things on this one, and this, I'm spending a lot of time on this one. I have another example to show if time permits. I'm going to quickly jump over to that actually. But this one really has it all. So I really wanted to show you kind of like, this is how deep you can go. And then I'll show you a little simpler example. So you can control your material. You can control, again, additional custom properties that might show up on your data cards or on your, the custom properties may drive something on the drawing. So all this stuff is important. Like my company wanted to know if it was RoHS compatible. In this case, the whole family is. So I'm driving that up here and setting this equal. It's a charted family. That's something that we wanted to be able to search in our PDM system. So that charted variable was set. And then there's this one called isFastener, which is interesting. That's a SOLIDWORKS property, and it's just a PRP at isFastener, and it just sets yes or no if it's a fastener. There are some tools within SOLIDWORKS where you can exclude fasteners. I think the interference detection is one of those. And so if you have this isFastener property in your model, it will recognize that as a fastener. I think that's inherent in the toolbox library, so I wanted to include that in my custom toolbox library here as well. And then the last thing is color. And this one again uses a formula. So you'll see the formula here says if the adjacent cell is set to black, then use this, and this is a SolidWorks integer that controls the color in SolidWorks. Else use this other integer. So basically I had two options. My parts are either no color, in other words, they're going to be like a silver gray color, or they're going to be black. And so that's as simple as I needed. I just need black or not. And so I have none or black as my drop down. Notice on this one that we just did, if I switch it to none, that integer changes ending in 14. If I change it back to black, then it does the 265. So now I'm going to click this. So this is the nuance with editing this not in its own table. You drag around these handles, but if you accidentally click outside the table, that's actually how you exit. You can also hit the green check, but clicking outside of this little window commits the change. So I'm going to do that now. And what you're going to see is SOLIDWORKS tells me, hey, I just noticed that the design table is asking to create a new configuration. I'm just making you aware of it. So this is important because it will also tell you if a configuration was removed. And so that's just good information to make sure what you did in the table is what you expected. And in this case, I did expect to create a new configuration. Click OK. And I come over here, and 19 was my 55 millimeter version. I created 20, and that's my, oops, and look what happened. My size did not change. My patch did, but I forgot to change the length. So now I'm going to come back in the table. And I'm not going to disable the drop downs, but I'm going to come in down here. I fixed my description, but I did not fix my actual value. So right here it says 55, and I want that to say 60. And the thread length after you get onto a certain length is the same at 22, so that's all good. And earlier I was showing you the pitch. I can actually do that by number of threads or by a specific length if I had a custom patch that I needed to apply for a certain application. All right, out of there. Now you can see between 19 and 20, I do have a different length and a different patch. So then I would just add that to my drawing table. So any questions on that?
I haven't seen any. I mean, Craig has basically said when working with PDM, make sure those fields are all read-only.
On the data card?
Yeah, which I think
Indeed. Yes.
that could probably cause
so
chaos.
your data card is going to display those fields and allow you to search by them, filter by them when you search, but you don't want those to be edited at the card level because obviously that's not going to come back and edit your design table necessarily. So nor would you want it to. You really want it to be a one-way street. You want the design table to drive when you're using them. So let me close. Let's see. We're going to close. Oops, it's on the screen. Close the drawing. We don't save it. And we'll close that. Not save it. All right, now let's open these other examples. So I'm going to go ahead and open the assembly. I know we're short on time. If anybody has questions, definitely ask. I want to make sure we get those answered. But I want to show you, and I'm going to kind of go bottom up on this, how I made this model, because this is a little bit simpler. And if we go to, I started out and I just made the end item, right? Oftentimes that's where we start. We have this model, and this is how what the final part looks like. But then I said, well, I really want to make this out of cast aluminum, let's say. So I started doing things like I added some draft and I added some extra material And I'd said, well, these holes are going to get machined in. They're not going to be as cast. This ID is going to be machined. So everything in red you see was intended to be a machined surface. So how did I get there? I went back, I created a new configuration, and I did this outside of the design table, by the way. And I suppressed I put all of my machined features in a folder, and I did my cast features first, just like in the real world. I started with my casting, and then I did all the machining, virtual machining operations, and I put them all in one folder. What that does, that allows me to very simply control it in the design table. So if we look at this design table, I didn't manually do anything. I basically created a new design table. In fact, let me just delete this table and show you how to create it from scratch. And hopefully this doesn't break my assembly too badly. So let's save it. So how do you create a table? Well, you'd think there would be a way right here in the configurations tab. I don't think there is. I think you have to go insert table if it's not already there. Insert table, Excel design table. Now I'm going to choose the auto create option, and initially I'll allow model edits for right now while I'm setting this up, and I'm going to say okay, and voila, it did a lot of the work for me. And so it already recognized that I've got 4 configurations, and here are all the things that vary. Now, I don't need to vary color in this case, so I can delete that one. Now the flange OD, this is one important thing. When I was setting up this model, I named my dimensions. I mentioned earlier, by default, dimensions are named, D1, D2, D3. Sketches are named sketch 1, sketch 2, and so on. You may want to name your dimensions and or features to make it easy on yourself, because it gets very confusing if you have a lot of variables with all of those just sequential numbers that don't mean much. That's where I was saying earlier, I could add a user notes row here and give them real names, or better yet, just name the features or the dimensions themselves, and then they're going to show up here with those logical names. So if I see a question, can we add design table icon and S key? I don't know. That's a good question. I have not tried that.
I was just about to reply then and just say, it probably wouldn't surprise me if you could.
Yeah, I've not tried
If
that. But
not in your mouse
insert,
gestures, I'm sure.
yeah, it's insert table. If you can assign a shortcut to that, then you probably can assign a button to it as well. All right, the thickness, the height, the ID, all those things I want to control. The state of the sketch, I don't want to control that. In fact, all of these features that are under machined features, the reason I put it in a folder, I don't want to control all these things individually. So sketch 3 is down here. I don't want that. I don't even want to do the mounting holes. All I want to do is the sketch 1. These are all in sketch 1. These are all sketch 3, 4. Let's see, all the way to machined features. Delete. Okay, machined features. Delete. So I've got my flange OD, my thickness, and my height, and my ID, the as cast dimensions, and then whether or not the machined features folder is suppressed or unsuppressed. And if it's blank, it's going to be unsuppressed, but I like to put a U in there. All right, now exit. And that's all there is to it. So my as cast large and my as machined large and then my ASCAS small, and my AS machine small. So folders are super helpful because you can just suppress and unsuppress everything at once. The other nice thing about that, if I suppress this feature called ID cut revolve, it's not going to suppress the underlying sketch. Well, I don't need that available to me if the feature is suppressed. Its only purpose is to drive the feature. So by using a folder, I'm suppressing everything, including the sketches. All right. Back to the assembly. So here with the assembly, now you see the two things come together. And in this case, what I did, again, I'm going to show you the table. And I could have created this the same way, and I'll show you that too. It's very simple. All I'm doing is saying which configuration of the model do I want to use, of the primary model, and which configuration of the screw do I want to use. The other thing, let me back up one. If I go back to this machine, I wanted to show you how to change the size of a hole. So I think I allowed edits. Yep, I'm allowing edits. So if I came down here and changed my, let's go to the small, and I want to change this from an M5. And if you had seen this before I did this the first time, this feature said M5 counterbore. So if you use the whole wizard, it's going to tell you the size as the name. But as soon as you vary that by configuration, it goes to a generic name of CBOR. This is what I want it. Or CBOR for socket head button cap screw, but it doesn't say what size. All right, so edit feature. I'm going to come down here under configurations, and I'm going to say, I only want to affect these configurations, the small, the as cast, and the as machine small. Now the as cast has it suppressed, but I'm still going to control it for both small configurations. And I'm going to click OK. And I'm going to change this to an M4. And I've already set my pattern to 3 instead of 6. Now I rebuild. Those are M4 now. I go into my design table. This is where it's going to come up and say, hey, here's all these new parameters. And most of them we intentionally are not using, right? Because they're all covered under that folder. But notice this one, HW size at counterbore. That's the one I want. So I'm going to select it and click OK. Now it adds to my design table. Now, this is the cool part. It's a dropdown. So I don't have to go back into the whole wizard again. I could add another one. I could add as machined tiny, right? And as cast tiny. And I could set those to match, right? With the formula. And I could say, okay, I really want this flange to be even smaller, 70. I'm going to go with thickness of 6 and a height of 30. And the ID is going to be 16. And I want to use M3 for this one. Exit. Now SOLIDWORKS is going to tell me it created these two new configurations. And if I picked good numbers, then it should look good when I switch to it. And it did. Let's say, oh, well, I did forget one thing in I want actually 4 holes here. So I'm going to come in and I'm going to change for specified configurations, the 2 tiny ones. And I only need 2 holes here, actually. So now, back to my table. And I've got to find that Mounting holes, D1. So here's a trick. Let's see. I think it's mounting hole. D1. Let's see. Yeah, that's it. So I've got 6 holes for the large, 3 holes, and 2 holes. Right. Now back to the assembly. This is the cool part. I now can go into my configuration, into my design table, I mean, and I can say, okay, I have this new configuration I want to add. I'm going to call it tiny. Oh, look, a drop down. Cool. I can just select it now, right? As machine tiny. And I'm going to get to this. I don't know what size. Well, I only have the M5 here, so but I can select. This is where I wouldn't be able to use the configuration of the screw because I was physically changing the size of the hole in this case, so my screw size would need to change. I would have to actually suppress and unsuppress a different component if that was a separate file. But I'll just choose a different example here just for the sake of showing you how it technically works if you're just varying the length of the screw in this case. So there you can see I've got my large, here's my small, there's my tiny, and guess what? All the screws are showing 2 screws, 3 screws, and 6 screws respectively, but that wasn't in my design table. That's because I used a derived pattern here. So let me delete that and show you how that works, and this will be the last thing unless there are any questions. So what I always do is I always use Hole Wizard, and I always use patterns or multiple instances within the Hole Wizard feature for 2 reasons. One, for this derived pattern feature, and 2, when I get to the drawing and I'm detailing out this part and I want to show the size of this hole, I use the hole callout, which references the Hole Wizard, which tells me the number of instances. So my drawing is going to automatically include a 6x there. And if I change that to 4, it's going to switch to 4x. It's going to be dynamically associated at the drawing level. So Hole Wizard, plug for that. A lot of people use simple cut extrudes for their holes. They get lazy. The Hole Wizard has downstream value, so definitely recommend that. So how do you create this derived pattern? It's right here, pattern-driven component pattern. And when I select pattern-driven component pattern, I've got my screw pre-selected. Now I just have to tell it which feature to use as the pattern definition. And if I select any one of those holes, it picks up where the other screws need to go. And then this is the key right here. Synchronized configuration of patterned component to seed. The seed is the initial part, and the patterned components need to be set to synchronized configuration because technically SOLIDWORKS will let you use different configurations of a component in a pattern. But by default, I wish it was this way because this is really what I want. And that allows me to use this design table. And now I can say, okay, I want, I'll use our, maybe I haven't saved, but let's do this one. Okay, it's driven by the design table. Interesting. Okay, so the state of my derived pattern shows up in this list. That tells me that I have a variance between my configurations, probably because I deleted it and re-added it. And by default, my other 2 configurations did not have that turned on. I do want that turned on. So I'm simply going to unsuppress them using the design table, go back in and delete that row because it's really not something I want to ever suppress. I do want those always included. And then I'm going to just exaggerate my large configuration with an extremely long version of my screw. I'm going to rebuild, and you're going to see that those screws are propagating and they're matching size in each of the configurations. So hopefully that gives you a good summary. I apologize for going so far over time. Are there any other questions? If not, you guys can feel free to reach out to me through LinkedIn or any other means. And happy to connect with you if you're trying to implement design tables for your application, you have something you're stuck on. I'm happy to help give advice or take a look at any problems you might encounter.
Excellent. Josh, do you mind just switching up to presenting? Because I wanted to show how you can add design tables to your S thing. I was playing around with that in the background. Window, no, entire screen. So it's not as impressive as your model. But I found if you press the S key and then while that's open, it should stay open, we'll go to customize, press the S key again. There we go, pops up. If you go down here to your tables, you find your Excel table and you just click and drag it.
Nice.
Into there.
Oh, there is a button for it already. That's cool.
If you go to your commands, I'll just switch to insert commands and I'll search for table. You can actually go to the Excel table and say, for example, Shift T. And now every time you press Shift T, you can insert a table.
Nice. So another example or another tip to add on to that, if you don't use design tables very often, yeah, add them as you need them. But if this is something like in my old company I mentioned, we use design tables for everything. We just put it into our template. So we had the design table already created in our part template and our assembly template. That way, every time we create a new file, the table's already there, and that gives you the opportunity to pre-populate those design tables with any kind of instructions or basic stuff. And another little trick, if you're having trouble with design tables and you want to go back to a single configuration temporarily while you're fixing your model before you add back in all the different tabulated configurations, just insert a blank row after the first row, and now SOLIDWORKS will delete those configurations, but you can get them back anytime by just eliminating that gap, and now it'll rebuild those configurations. So there's a lot of tools and troubleshooting. Another thing I didn't mention is if you have a syntax error, you'll see when you exit the design table, it will flash up in the top right and tell you, typically give you a clue as to what's failing or what the problem is. Another thing, if you are adding features to, instead of just relying on that pop-up dialog to add your dimensions and your variables, like I like to go and do a manual change and just have it automatically add. But another thing you can do is under annotations, Kirby, if you right click on your annotations folder, and I'm assuming you have a dimension. I don't know if you applied, well, you will have at least a thickness there, but show feature dimensions. And notice that you have the thickness showing there. So if you open that design table up and that is visible on your screen, and you can hold control and kind of pan around behind that window without exiting it, it's a little tricky. But if you kind of set it up to where your design table and your model are both showing on the screen at the same time, you can double click on that dimension and it will add to the table.
Yeah, I don't have Excel installed on this computer. I learned
Okay.
very hard way. If you don't have it,
yep,
it's not even going to attempt to work with. It's not enough.
Prerequisite. Unfortunately, it's you get the embedded tools, but you do have to have the software installed.
Yeah. Yeah. Thank you very much for that awesome presentation. I'll do my little wrap up here. You guys have already registered for this, so you'll see any future upcoming events coming up. I've got one planned for next month, and hopefully soon I can organize a in-person meeting in London. If you want to find any other cool user group meetings or interesting things, come to the swaggin.org website. Like I said, there's literally user groups all around the world that you can visit. And if you come across here, you can see all the upcoming events, as well as searching the calendar. If you're local to the UK, Solid Solutions puts together a lot of great events. One that's coming up soon, the 1st of October, is a technology showcase. It's basically a bunch of how SolidWorks can be used with various different technologies, as well as some tips and tricks, presentations going on throughout the whole event. And today I found this YouTube channel today. I just thought I'd add this in here. This is like, 15-minute quick user group meetings, just showing some cool ways of designing and ways of thinking, especially if you are looking to be on the more professional side and manufacturing side of SolidWorks. I will post these links all in the chat so that everybody can have a look at them. But yeah, that's all we have for today. I really hope everybody's enjoyed that. I'll paste that. Can't think and do things. Yes. So yeah. Thank you very much, everybody, for attending. If anyone still has some questions, please fire away. If not, you can post discussions in the Swaggin page. And yeah, hope everybody enjoyed it.
Awesome.
Excellent. And thank you for presenting, Josh.
Yeah, happy to answer any questions. If there are none, thank you all for your time, and hopefully you found it useful and can find a way to implement it on your own.
Excellent. Cool. Thank you, everybody.